Okay, for this problem, we want to set up the null hypothesis as the coin is unbiased, meaning the probability of getting ahead is 0.5, and our alternative hypothesis is it is biased toward head. That means the probability of getting ahead is more than 0.5. So this is a one-sided test. If the question asks you if the coin is biased but didn't include the two toward head, then that's a two-sided test. That means like the alternative hypothesis p is not equal to 0.5. But this question is a one-sided test. So we're assuming that our hypothesis is correct and say that if we can reject our null hypothesis. Since each trial is each time we flip a coin, that's a binomial, that's a Bernoulli random variable. So the standard deviation of that is equal to the square root of PQ, where Q is defined to be 1 minus P, which is the failure rate. So that's the square root of 0.5 times 0.5, which is 0.5. So then we want to do the z-score. We want to find the z-score. And to find the z-score, we need x bar minus mu bar divided by sigma bar. So mu bar in this case is mu over square root of n. And since we're doing 100 trials, so the n is equal to 100. So the result of sigma bar is 0.5 over square root of 100, which is 0.05. So the z-score here is just 0.5. Wait, no. So the z-score here is we first look at the x bar. X bar is our measurement on 100 results, and out of 100 results, we get 55 heads. So the average is 0.55 because 55% of them are heads. And the actual population average, if we assume the coin is unbiased, is 0.5, and we need to divide it by sigma bar. So that's precisely 1. That means it happens at 1 standard deviation above the mean. And so the graph of that would be this is mean, and this is our z-score of 1. That's exactly 1 standard deviation above. And the p-value is the area in this region. So we do a z of 1, and z of 1 is this region. So the p-value is equal to half minus z of 1, which is half minus 0.3413. Z of 1 is 0.3413 by checking the z table. The result of that is 0.1587. So now we want to compare our p-value versus critical value alpha. So p-value is 0.1587, and our critical value is 0.05. So we know that our p-value is greater than our critical value. So we can't reject our null hypothesis, and then we can't conclude that the coin is biased toward head. Yeah, and just to like remind you that the idea of p-value is greater than the critical value alpha is because my p-value is around here, and my critical value alpha is somewhere here. And the blue region is the rejection zone, but my p-value doesn't lie in rejection zone, so we can't reject our null hypothesis. Yeah, with that in your mind, maybe you can like work on problem 2 and problem 3. And update with me your progress on solving these problems. Yeah, up to now, none of you has updated me with your progress on solving problem 2 and 3. If you finish, please tell me you finish. And if you don't finish this problem, you can like move forward, because in class we have like different pace of problem solving. So I just want to know like what are the average pace in our class, and I will set up my pace on the average pace. Okay, so maybe I should talk about problem 2. So let's read the problem together. Suppose the IQ score for alien children are normally distributed with mu equal to 100 and sigma equal to 15. An alien educator has developed a software intended to increase the IQ score for alien children while they sleep. All alien children try the software, and then a random sample of 144 alien children are retested, resulting in a sample mean of 101. So n is equal to 144. That's the information we get after reading the problem. So part A, do we have enough evidence to start the mass production of the software? So meaning that our null hypothesis here is that the software is not effective in our so meaning that our alternative hypothesis is that the software is effective on increasing students' IQ score. Yes. So so we want to set up. We have already set up this experimental frame, and we want to do a z-test on that. So z is equal to the sample mean, which is 101 minus the mu, which is the population mean, which is also equal to the sample mean. So it's S bar minus mu bar divided by sigma bar, which is 101 minus 100 divided by so remember, like sigma bar is equal to sigma over square root of n, so that's 15 over square root of 144, and that gives you 0.8. So essentially, we are finding the probability. So we are finding the p-value, and p-value corresponding to the probability of b greater or equal to 0.8. So on the graph, it means this is our mean. This is the score of 0.8, and we are finding this area as our p-value. So that's equal to half minus the z-score of 0.8, which is 0.2119. But the p-value So we now compare p-value versus alpha, which is our critical value. P-value is greater than alpha 0.05. Yeah, I guess since the question didn't tell us, we're assuming that alpha equals to 0.05. So that means like we can't reject our null hypothesis. So we don't have enough evidence to show that the software itself is actually effective. And for part B, we're basically finding the critical value and rejection zone. So remember, if we want to find the rejection zone, or that is related to finding the critical value, and to find the critical value, you need the significant level. Or maybe previously I set critical value as alpha, but alpha is significant level. Sometimes I like mess up with saying the term. So to find the significant level, we need to do it in a reverse engineering way. So we know that alpha is equal to 0.05. So that means on the graph, there is a point when this area is equal to 0.05, and this is our threshold for rejection zone. And that means this area here is 0.45. But that 0.45 is precisely the z-score at this point. So z-score of something equal to 0.45. And what's that something? Like, let's assume that the value of this point here is k. So that means the z-score is k minus the mean, which is 100, over the standard deviation, which is 15 over square root of 144. So we just want to do it reverse engineeringly. We look at the z-score table and we find that the value for 0.45 is 1.64. So z of 1.64 is 0.45. So that means k minus 100 over 15 over square root of 144 is 1.64. So k is equal to 100 plus 1.64 times 15 over square root of 144. And this value is calculated to be 102.5. So the rejection, so this point is 102.5. So the rejection zone is 102.5 to positive infinity. So everything on the right hand of this threshold. And for part C, what if anything will change if you didn't know sigma, but you are giving a sample standard deviation? So we just like nothing will change. So we don't change our calculation. Instead, we'll just like take this sample statistics as given, and we'll treat this as our population standard deviation. So we will treat this sample statistic as the population standard deviation and do the same calculation. So I'll give you some time to work on problem 3. And I believe there was a question in the chat. How does it being normally distributed impact your calculation? I don't really get the question. So, I mean, in order for you to do a z-test, so remember, like the criteria for doing a z-test is it has to be like the different samples has to be like identically distributed, independent and identically distributed, and the set n has to be greater or equal to 30. But that's and I believe Sylvia asked a question last time about, because the other problem n is equal to 25, but we are still doing a z-test. And the reason of that is because it's not wrong to do a z-test for n equals to 25 or like smaller to 30. It's just like it doesn't give you very accurate results in this situation. And we want to there's a theorem saying that when n is greater or equal to 30, that we can almost guarantee that our distribution will be a normal distribution. So that's why like if we have like 30 samples, we can automatically use z-test and treat that as the normal distribution. And the reason for us to use z-test is because we have to make sure that it's normally distributed in order for us to do the work. If it is not normally distributed, and we are using a normal distribution to estimate, that means we will get a not very promising result. So maybe a question related to problem 3. So since we have like only 8 samples, it's like the sample size is very small. If in this case instead we use the z-test, like the distribution of that might be like pretty different with the actual smooth curve of normal distribution. So instead we use the z-test, we might get very inaccurate results. So instead we are just calculated by hand and appeal to the definition of p-values. And again, like I remember one student from my previous section asked a question that is also related to t-test. So the question is basically why we can so I can like translate this question into z-test. So the question is basically why can we why is it both like valid on small sample size and n is greater or equal to 30 for z-test. So z-test is valid on this z-test is valid on this sample size greater than 30, and it's very preferred to use that. It's preferably to use that, but it might provide you inaccurate results. But the ultimate reason for us to use z-test is to draw conclusions. Is to draw conclusion whether we can reject our null hypothesis or not. So if the sample size is not too large and it does impact our results, we definitely don't want to use that for the test. And also in this class, we're encouraged, we encourage you to like, I mean, like it's basically not encouraged. Like in the test, you have to use the test if n is greater or equal to 30. So that's something that we have to you to do. And we'll probably never give you like confusing numbers. If we want you to use the test, the sample size will be definitely larger than 30. And if instead we want you to compute it by hand, the sample size will be very small. And if we encourage you to use t-test, the sample size will always be pretty small so that it will avoid confusion. So maybe we can look at problem 3 right now. So you think a coin is biased. It's either toward heads or toward tails. And if you flip a coin 8 times, you get 7 heads. Can you see that the coin is biased? So we want to first set up this experiment. So our null hypothesis is the coin is not biased. So that is when the probability of heads is 0.5. And our alternative hypothesis is that the coin is biased. So that means the probability is not equal to 0.5. So that's a two-sided test. If I say, if my question is, if the coin is biased toward head or not, then that's a one-sided test because I'm just looking at if the probability is greater than 0.5. But right now I'm looking at the probability is not equal to 0.5. Okay, let's go into closing again. Okay. So for this problem, we actually want to go into the actual definition of p-value. So say we have we flip a coin 8 times. So the expected value, which is also equal to the mean, is n times p, n times 0.5, which is 4. Like on average, there will be 4 heads and 4 tails if the coin, if we assume that our null hypothesis is correct. And then we want to calculate the p-value. Remember, in a normal curve, the p-value are the tails. Like since we're not doing z-test because the sample size is too small. But remember, for the normal curve, the p-values for two-sided tests are the two tails of this distribution, where like the threshold of this tail is the measurement. So the same idea appears in our problem solving. So the threshold for the p-value calculation, if you calculate manually, is also like our measurement. So our measurement result is that 7 heads out of 8 flip. So on the right tail, the p-values are px equal to 7 plus px equal to 8. So that's the tail of 7 heads and 8 tails. But remember, this is a two-sided test. We also need to plot the left tail, which is px equal to 1 and px equal to 0. And each probability follows a binomial distribution. So for example, for x equals 7, that's a choose 1 times 0.5 to the first and 0.5 to the seventh, which stands for the success and failure time. So that's the same thing on the other 3 probability. And then at last, we will get 0.07. So the p-value is greater than alpha, because alpha is 0.05. So that means we cannot reject our null hypothesis that we said the coin is biased. So we cannot say that the coin is biased. Yes. So that's it for problem 3. And then we will move forward to the t-test. But before we do anything about t-test, let's do some review on the gamma function. So basically, gamma function is pretty independent with the t-test itself. It's just in the calculation of the t distribution that we need the gamma function for us to simplify our equation and to calculate the result. Yes, so let me look at the lecture note. So gamma function is defined to be n minus 1 factorial. N minus 1 factorial, but like for n is integers, it's easy to calculate. And if n is integer, and just like to mention, like I will not answer question when I'm talking about things, and then I will answer your question when I will leave you for like doing the problem. So there might be a delay for answering your problem. So yeah, but the actual definition for gamma function is the integral from 0 to infinity, Tx minus 1 e to the negative t. So that applies on all x or on all n, matter which one you prefer. But like we have tell you that the gamma function of 0.5 is square root of pi. Like theoretically, if you want to calculate that, you need to plug this in to the gamma function definition and calculate the result. But like it requires some like multiple variable calculus problem. So so like you can just take this for granted. Instead, like why is it helpful? Some like usually in this class, I think at most we will give you some like 1.5 or gamma of 2.5 that you need to evaluate. So you can treat this as directly and apply that using the gamma function. And maybe I will leave you to do the work. So maybe let's do problem 3 on section 2. Oh, all right. Thank you, Sophie. Yeah, I think your answer gets solved. Yeah, and one thing I want to emphasize is that when we are doing a two-sided test, and we are giving the critical value, for example, alpha equals to 0.05. If that's a two-sided test, that means we need to like cut the alpha into half and look up that value in the Z-score table, instead of like looking at the original critical value, because usually we are doing two-sided and we are cutting the critical value into half. So that's just something worth noticing. And and let me know if you finish problem 3. Yeah, let me know your progress on solving problem 3. Yeah, currently no one has updated me with their progress now. And after this problem, I will do a poll for taking the discussion attendance. Okay, problem 3 should be a pretty simple problem. I don't know why it take all of you so long to do that, or you guys just not updating with me. Okay, so so for problem 3, we're looking at the PDF for T distribution. So like just don't be threatened by this T distribution. It's just like a bunch of formula. Essentially, all you need to do is just plug in numbers. So new here is like this notation is called new. It's just the degree of freedom. And for like a t-test, we take degree of freedom as a parameter, as a constant. Yeah, and x is the variable. So this is a PDF, just like the normal curve, where you have like mu and standard deviation as input, and x is a variable, and you are calculating the PDF of the normal distribution as well. That's the same thing. It's just like in a different form, maybe a little bit more complicated. So we know that we have already know this, and this, and x is a variable. So all we need to do is calculate the gamma function. So one thing worth noticing about the gamma function is that since gamma is defined to be gamma of n is defined to be n minus 1 factorial, gamma of n minus 1 will be defined to be n minus 2 factorial. N minus 1 factorial is equal to n minus 1 times n minus 2 times the times up to 1. So this part is n minus 2 factorial. So equal to n minus 1 times n minus 2 factorial, which is n minus 1 times gamma of n minus 1. So it's kind of like a recurrence relationship here. So here, since we're given that mu is 3, so essentially we are finding the gamma of 3 plus 1 over 2, which is gamma of 2, and the gamma of 3 over 2, which is gamma of 1.5. Gamma of 2 is easy to compute. Remember that gamma of n is just n minus 1 factorial. So gamma of 2 is just 1 factorial, which is 1. Gamma of 1.5, look at this recurrence relationship here. It's equal to 1.5 minus 1 times gamma of 1.5 minus 1. So that's 0.5 times gamma of 0.5. Remember, gamma of 0.5 is something you can take for granted. With equal to square root of pi. So this value here is 0.5 times square root of pi. So if we plug into the original big chunk of function, so we basically just plug in nu and the gamma we just calculated. So that's 1 over square root of 3 pi times 1 as mu of 2, and 0.5 times square root of pi as mu of 1.5 times 1 plus I square over 3 to the negative 2 plus 1 over 2, which is 2. So that's our result for the PDF of degree of freedom equal to 3. So I don't think you will have a problem on that. It's basically notation and plugging in and algebra calculation. So let's do some review on t-test. So what is t-test? T-test is basically happening when we are doing a d-test, but sometimes the sample size is very small, and this score doesn't provide you very accurate results. But oh yeah, maybe we should do a poll right now for taking the section attendance in case I forgot. Yeah, launch poll. You have 2 minutes to do this poll. Okay, I'll give you 1 more minute to do the poll, and I will close it at 2.5 minutes sharp. Okay, I'll close the pool. And also like just a side thing that you shouldn't like. I mean, if you want to leave the discussion after the pool, you should like at least like after me finishing the pool. Like if I didn't close the pool, I didn't get your results. Like I believe one student just left before I closed the pool. So like so originally there are 23 participants in this one, and then like I would say like 22 of them are voted in the pool. But if you left, the pool automatically changes to 22 participants and like 21 votes. That means like it got rid of the one who voted and left. So that means it doesn't take record of you attending this section. So I don't know, like if you want to leave, you can leave it now. Like I have your attendance already, but like don't leave it before I close the poll. Yeah, that's something I want to emphasize. And also like it will be preferable if you don't leave the section if you like didn't master all the knowledge. So actually the answer for first problem is false. So the reason why it is false is because the word valid. So it's not like just so in fact z-test can be used for small samples as well. Like it can be used for lower than 30, but sometimes it's just not too accurate. But like t-test can always use in a larger sample size. Actually, if you look at the t-tables, it gives you like degree of freedom equal to 40 or 60 or 80 or even 100. So that's something worthy to notice. They can like they are like both valid in all sample size, but sometimes like when sample size is larger, they test is better for getting the result. And if the sample size is smaller, we are definitely using t-test for more accurate results. And but for this class, specifically for this class, if you're in a test and we tell you that the sample size is greater than 30, and you are expected to use the test. And if the sample size is somewhat like if it is smaller than 30, and I believe we will never give you like sample size of 28 or 29, something like that. It would definitely be like 10 or 15 or 5. In this case, you use a t-test. And for second problem, the gamma of 100 is equal to 99 factorial. So that's exactly the number of different ways that 99 people can be arranged in a line. So the answer of that is true. Okay, so let me review something about t-test. So t-test is when we handle small sample size. And we just look at the curve for the PDF for t-test. But like with similar to normal distribution, we don't focus on too much about the PDF. Instead, we're focusing on doing the specific hypothesis testing. So for doing t-test, essentially you are doing the same process as if you are doing a z-score. The only difference is that you're looking at a t-table, and you are finding the t value instead of z value. So in order to check a t-table, you need several parameters. The first one is if it is a two-sided or one-sided test. The second one is the degree of freedom. So like this new here for degree of freedom. And the third thing is the significance level alpha. So you need these three parameters. You need to like know exactly these three parameters, and then the t table it will show you like you look at t table to find t values based on these three parameters. Yeah, so maybe like we can look at problem 1 for now. Yeah, and update with me your progress on solving this problem. By the way, I just received an email from Danny. Like, do you guys know like how do we handle the mail plans, like the flex dollars and mail plans in the account? Like, does anyone know about that? I have no idea how do I still have some $100 flex dollars inside. I haven't used that. Does it like automatically be sent to your next semester's account or no? Oh, I can request a refund. Oh, okay. Oh, thanks for telling this to me. Otherwise, I'll probably lose $100 or $200. Yeah, and also like for those who haven't filled out that form yet, it also like reminds you to fill out the form because otherwise you might also like lose some money. Great, thank you very much. Yeah, and also I received some request like quiz correction for quiz 11. Remember, like if you do wrong on problem 2, for quiz 11, you have a chance to do a regrade request for the quiz correction. And I haven't graded quiz 12 yet. I will probably grade it either today or tomorrow. And after grading that, you'll be able to do a regrade request for that as well. For quiz correction as well. Like I'm planning to give you a better score on I'm planning to make sure that after you're getting your final letter grade, it is not because of me who are dragging your letter grade down if you are in the boundary of 2-letter grades. I just want to make sure that if you're, for example, if in the boundary of B and B plus, I can boost your quiz score and homework score so that you can jump into the B plus instead of getting a B. Yeah, so that's why yeah, I guess if you get for those who didn't fill out the course evaluation, please do fill the course evaluation and possibly give me a good response if you think I'm good. And so I will provide all of you an opportunity to do the quiz correction on any of the quiz you want throughout the entire semester. And next quiz on Tuesday wouldn't be, yeah, the course evaluation is anonymous, but I can see the response rate. Yeah, but yeah, I mean it's anonymous, but don't give me if you really want to hurt me with low evaluations, just don't do that. Don't send me the course evaluation, I guess. I mean, for the regrade request, it's definitely due by the sometime in RR week, but since there's not enough people who haven't do the course evaluation yet, so I haven't set it up the system already. So by Tuesday, I will tell you the result of the response rate, and I will tell you if we are actually doing that also. But I'm pretty sure that most of you will, because right now already more than half of you have responded to the course evaluation. I'm pretty sure that most of you will respond. And quiz 13, which is the last quiz, will be also not hard. So I would recommend you to attend on Tuesday and do the quiz. Yeah, so for all those logistic problems, I will either address it on next week, or I will make announcement somewhat. Okay, so what I mentioned is that there are specific quizzes that you can do quiz correction that I usually have make announcement in class, or sometimes I make announcement on B course. For quiz 11 and quiz 12, I allow you to do quiz correction. For quiz 11, I allow you to do quiz correction on problem 2. And for quiz 12, I allow you to do quiz correction on the entire quiz. But I haven't finished grading quiz 12 yet. And remember, there was one or two other, maybe one other quiz, is that either quiz 8 or quiz 9. I also allow you to do quiz correction. But other than all these things, if my course evaluation response rate gets high enough, I will allow you to choose whatever quiz you want. But usually the one you choose are the lowest score you receive. For example, there might be a 3 or 4. In this situation, I will allow you to, or in fact, you might not choose to do the lowest. Okay, so actually you need to choose the one that is the fourth lowest score. So that because we are dropping 3 quizzes, if you boost the fourth lowest score by some extent, your final calculation. So what matters is not the lowest 3, it's the fourth lowest quiz. Yeah, that's what it is. So basically, I'm loyal to, other than all the quiz question I allow all class to do, I allow your individual to choose whatever quiz you want to do a quiz question. Does they answer your question? Like, I think if you didn't respond to me, I assume that it's clear for everyone. Yeah, I mean, all I'm doing this quiz collection thing, for one thing, like, you will know why you are doing it wrong. And for the other thing, it can also boost your score. Yeah, but like, this is just something I did in my sections. Other JSI are not doing that. So like, just definitely take this as your advantage to boost up your score in the entire class. Yeah, and don't forget, when you're doing the quiz correction, there are some like requirements. You need to like do the quiz correctly, do the solution correctly, and identify why you are doing wrong, and write a short paragraph saying that in general, for this type of problems, what are the problem solving strategy? What are step 1, step 2, step 3 to do this problem? I want to say all these 3 steps for you to get your points back. Yeah, I guess I talk about a lot of logistics. And only have 10 minutes left, so I guess I need to like go through problem 1. If you have like problem about logistics, you can always ask me through email. Yeah, and usually the one who ask me get like things answered more clearly. So for problem 1, in a general population, the heart rate are normally distributed with a mean of 72 beats per minute, and the heart rate of 40 patients. So n equals to 40. That's our sample size. And we will have an identical, and our like X bar is 95.3 beats per minute. So that's for all the patients in ICU. And we're giving the standard deviation is 16.9. So the question is, are heart rates of ICU patient and euro? So that's some details that we need to notice. The question asks you if the heart rate of ICU patient and euro, instead of asking you if their heart rate are higher than normal. So that's different. If I ask you n euro, that means different from normal. The difference from the normal mu equal to 72. So that means mu doesn't equal to 72. So that means the two-sided test. But if the question asks you if the patient has higher heart rate than normal, like specifically higher heart rate than normal, that means mu is greater than 72. Then that's a one-sided test. So that's some detail that can be tricky when you are doing exam. If you are doing it on one-sided instead of two-sided, you lose points automatically for this problem. So let's go to part A. Part A asks us calculate the degree of freedom. So the degree of freedom is n-1, which is 14 minus 1, which is 39. Like this how we define degree of freedom is the sample size minus 1. And then part B, we want to calculate the t statistic. So remember, the t statistic is just the same thing as the z-score. But like we're just handling it as a t statistic. So the way to calculate is the same. You do x bar minus mu divided by sigma. In this case, is 16.9 divided by the square root of n, which is 40. So that's our t statistic. and that evaluated to 8.72. So now in part C, we're actually doing the actual experiment. So the experiment setup is we need to write null hypothesis and alternative hypothesis. The null hypothesis, in this case, as what I mentioned before, is the heart rate that is normal. Heart rate is normal, which is mu equal to 72. And the alternative hypothesis is heart rate is not normal, abnormal, which is mu not equal to 72. So this is a two-studied test. And then we need to look up the t table to find the specific t value for this testing. And how do we find it? We look at, given that the parameter for significant level is 0.05, and we are given that this is a two-studied test. And we are also given that the degree of freedom, nu, is equal to 14 minus 1, which is 39. So with all these three parameters, we look into the t table, we can find the value of t. In this case, it's 2.02. So what does this mean? That's the same thing as z-score. In a distribution, the t value is 2.02. Because this is two-sided, we also need to care about the negative side, which is negative 2.02. So the idea is that given this significant value and two-sided test and degree of freedom, we get this 2.02. And all the areas on the extreme side of this value are our rejection zone. So remember, like on part B, we calculate t statistic equal to 8.72. So 8.72 definitely lies on the rejection zone. So that means we can reject the t value. Now we can reject the null hypothesis. So we can reject H0. And that means we can conclude that the heart rate in the ICU patients are n euro. The 2.02 comes from looking at the t table. So I don't know if Professor Sankova provide you a t table or not. If not, you can just like look it up online. So the thing I look up is I look up t table, and then the first thing come out is a PDF of a t table that shows you the degree of freedom and the significance level, and whether it's one tail or two tails. So you can find 2.02 in that table. And then as what I mentioned, here the only important thing is that you need two-study test, degree of freedom, and significance level. These three parameters to look into the t table to find the value for the t-score. Okay, so for part D, so since like the sample size is actually 40, yeah, that's exactly what I mean. So what Sylvie said in the chat. So for part B, the sample size is actually greater than 30. It's actually 40, and we are using t-test to do that. We can do that, but more preferably, we should use a d-test because it's more common in practice. So the problem itself gives you a way to provide you an estimator for the true population mean, because in this question, standard deviation of 16.9 it's a sample standard deviation. So like the question tells you like the estimator for the population standard deviation is by the square root of n minus 1 over n times s, which is 16.7. Like this, I also like when I look at this problem, I also like forgot what's the notation in here. So I look back into the lecture when we are talking about estimator. So it gives a pretty clear a derivation of this. But for this question, you can just like take it for granted. So the z statistics here is x bar minus mu bar over sigma bar. So in this case, we use this S star as an estimator to estimate sigma bar. So the z-score in this situation is 95.3 minus 72 over 16.7 over square root of 40, which is roughly 8.82. And remember, like we were calculating the z-score, we're finding the critical value, and the critical value is 0.05. Yeah, and it's also like corresponding to what Sylvie asked in the chat. The question about that, because we are giving this significant level, and then we look at the normal curve, and then we find that it is because we want this is to be two-sided. So this area here is 0.025, and this area here. So that's like because this is significant level and this is two-sided, and each side will share 0.025 as the boundary. So if we were to find the z-score, this area will be 0.475. And then we're essentially finding a z-score, like what input to the z-score do we find 0.475? So that's why we get this value equal to 1.96. So essentially you're checking the t-table, you're undergoing this process of giving you the significance level, and we are telling you this two-sided test. And we're also giving a degree of freedom. So this is basically the same thing, that we are giving a z-table, and we are giving that significance level is 0.05. We're giving that this is a two-sided test. So we can look at the table and do the reverse engineering to get 1.96. That's the same thing. It's just like one is z-table and one is t-table. So what does this 1.96 mean? The 1.96 means at 1.96 or negative 1.96, these are my rejection zone. And as in previous part, we calculate that this statistic is 8.82, which definitely falls in the rejection zone. So again, we can conclude that we can reject our null hypothesis. And the conclusion is that ICU patients' heart rate are on euro, which is the same thing as we did for the t-test. So as you can see, in most cases, whether you do a z-test or a t-test, the value doesn't change because 8.82 is significantly larger than 1.96, and 8.72 in t-test is significantly larger than the threshold of 2.02. So it doesn't really matter. As the only thing is, as long as our conclusion is correct, our conclusion that ICU patient heart rate on euro is correct, is enough. Yeah, so I guess that's it for today, and I'll leave here. I'll stay here for 1 more minute for answer any problem you might arise. Otherwise, you're officially dismissed. Thank you, guys. Okay, for those who stay, do you have a problem, or you just like stay connected but not showing up? Jody, do you have a problem? Like, remember you sent me an email and I have replied it to you. All right. So I guess you guys don't have any problem, and I will end the meeting right now. If you do have a problem, you can always send me an email or drop in during my office hours.